So my name is Mayo. Full name is Mayowa. I go to University of Houston. I'm a computer engineering student, and I basically what I do on my for the rest of my days is code in C++. So I actually came over an assignment that asks about B trees and how to implement it and print from a B tree. And thinking about it, it was very hard to find answers to how to do this. So I'll be going over how exactly a B tree works and how to code it in C++. So this video is going to be long, so I'm going to break it into two parts. The first part is just me explaining how the B tree works, and then we have the second part of me actually coding how the B tree works. So let's get right into it, starting with how a B tree works. So to even start with, in computer science, data structures, we have these data structures called trees. Now, trees is basically like a way to put in like data in a tree like format. So you know how a tree looks. It has branches, it has all this, it has all this. Yeah, it's a very ugly tree, but this is how a tree looks. So basically in data structures too, we have stuff called trees. We have trees that hold data in it. So we have different kind of trees in data structure, and it looks kind of like this. And this can hold an integer, it can hold 2, it can hold 5, it can hold a string, it could have name, it could have John. It could literally hold a lot of stuff. So there are different kind of trees. We have AVO trees, we have BST trees, we have normal trees, we have red-black trees, and we have B trees. Actually, we have more, but these are the common ones. And BST tree is the most common tree. So BST tree it has the greater values on the right, and it has the lesser values on the left. So that's what a BST tree is. So if you have 5 here, then this would contain like 4, and this will contain like 6, and this can contain like 2 and 1, and this can contain like 8, and this can contain, since this is the right, this can contain like I don't know. Yeah, this wasn't a good example, but this can contain something. Maybe what is less than 6? 5.5. Yeah. So that is a BSC tree. Today we're not talking about BSC trees, we're talking about B trees, because whoever is watching this video already knows what a BST tree is. So let's get right into the B tree. A B tree is basically like a BST tree, but it's not. Now, a B tree, apparently they use it for hard disk. So when we have like a disk, and then this disc has different tracks, and your old recorder player, and you're playing the track, and you want to like move through the song. It has this line that goes through the entire CD, and if you change track, it moves up and down. So apparently, this data that is stored in the tracks is actually they use a B tree to store it. Now, what is a B tree? Now, a B tree is, let's say, it looks more like a square. It's a square-like tree. So in this square-like tree, we can have a value. So let's say we have a value 5. In this same node, we can have another value 8. In this same node, we can have another value 9. And then this can have a child with another node that can have various values too. And this can have another child with another node that can have various values too. Yeah, sorry about that. You can have a child with another node that has various values too. And then, and so on. So how does a B tree work, and what are the rules? Yeah, you guys are not going to really see much of my drawing because I'm not much of a writer or drawer, but I code. So let's get into like how a B tree works. So a B tree, the rules of a B tree is, so a BSC tree can have a leaf at one side, and then at that same level, it may not have a leaf. It could have children. But a B tree, all leaves are on the same level. So leaves, same level. That is the thing about a B tree. What else do we know about a B tree? A B tree, so in this node, inside here, we have something called keys. Now, these keys these keys can only be a certain number. Now, how do we know what certain number these keys are? There's something called a degree that somebody would ask you when you're putting into a BTree. So this degree, like somebody says a degree of 3, the degree could mean different things. This is something I actually didn't know during my entire research of this. So sometimes somebody may ask like a BTree of a max degree this, or they could say a BTree of a min degree this. Now these are two different things. I'm going to get to why it is. So a BTree of a max degree, let's say of a max degree 4, right? It means it can only have 3 keys in it. So it can only have 5, 9, and 10, and it can only have 4 children. So yeah, small blocks. Forgive my drawing. It's raining. It's a long day. What's today? Yeah, let me not say the day because somebody may be watching this 10 years from now. But it can have 4 children. It can have 3 keys. So what exactly is this max degree? This degree is basically like the rule. It's a rule for the BTree. So if I say create a BTree of a max degree 4, it's gonna have 3 keys and 4 children, and in this children, it's gonna also have 3 keys, maximum of 3 keys. So maximum of 3 keys is what the BTree would have. I'm not saying it cannot have only 1 key. It can have only 1 key, but maximum of 3 keys. And if they say a main, if they're talking about main degree, and they say a minimum degree of 2, then what they actually mean is a minimum degree of 2 is basically a maximum degree of 4. Because this mean degree is actually multiplied by 2 minus 1 to govern this rule. So if they give you a mean degree, you're going to have to do 2 times 2 minus 1, which is 4 minus 1, which is 3. And that is the rule that governs this tree. There are different things, guys. People don't say this online. I don't know why, but I got stuck on this for a while. But yeah, there are different things. So while switching gears, yeah, my drawing kind of sucks. Let me show you really how this looks. So I'm going to go in and show you the visualization of this. So look at this. Yeah, I shouldn't be saying that. A BTree visualization. Alright, can you guys see this? So this is a BTree visualization, and they have the rules that's going to govern this BTree. So let's say we want a BTree of a max degree 4. Now let's start inserting elements. So to insert the first element, I put in 228. I insert it. You see, it's like a square block. It has just 228 in it. Now I put in 72. I insert 72 into it. Now watch this. Watch this. Because my max degree is 4, and this BTree can have a maximum of 4 minus 1, 3 values, then that means this 72 can enter. But you can see this 72 was put right in front of it. So this BTree is actually walking in ascending order. It finds the right spot to put it. Let me just step back a little bit. This was 228 I put in. I'm inserting in 72. I put in 72. Boom. It put it right in front of 228. It didn't put it after. So 72 was smaller than 228, so they put 72 right in front of it. Alright, let's keep putting in stuff. I put in 228, now I'm putting in 177. Inserting you see, so 177 is put behind 72 and before 228. So it's right after 72, right before 228. You know, because 177 is bigger than 72 and it's smaller than 228. Now, watch this. Right now we have 3 keys. And what was our degree 4? Meaning that we can only have 3 keys. Watch what happens when I put in a different value. I put in 9 now. The same rule. It goes in, it checks for where we can place the 9. 9 goes right before 72 because 72 is bigger than 9. And now watch this. Because we have 4, meaning it has violated the rule. Meaning we have 4 keys and the degree is 4. So we're only meant to have 3 keys, but now we have 4. We have to split it. Now this is what happens. This is how the children is being created. The children is being created like this. We split it and 72 goes up. Why does 72 go up? I'm going to explain that. Look. We have 9, 72, 177, 228. We have to make the median go up. Meaning we have to make the median the median value in the node be the one to go up and make the remaining the children of that value. Don't ask me why that is. I know why it is, but it's a lot to explain. I'm just going to show you that. So step forward, 72 goes up. Now look, right now 72 has 2 children. What happened there? Let's go back and see. The reason why that happened is because once this goes up, this splits into 2, meaning the stuff that was before 72 goes to the left, and the stuff that was after 72 goes to the right. And that is the rule that governs the entire B tree. The rule is you insert a value in, you can keep inserting a value in a node. If that node becomes full, meaning if that node is equals to the degree, then we split it. To split it means that we have to push the median up, and then we have to split that into 2. Anything that was before the median goes to the left, anything that was after the median goes to the right. That's basically what a B tree is. So pushing forward, let's insert more values in. Let's insert 284. I'm inserting 284. Oh, inserting. Let's step forward. So it goes in here. It always starts from the root when it's looking for where to insert it. So another rule of the B tree is start from the root, look for where to insert it, but always insert at the leaf. The B tree would never insert 284 in the root, or if there are children, it's never going to insert it in the children. It's always going to insert at the leaf. What is a leaf? A leaf is basically it has no children. So that is basically the bottom. The bottom of the tree is the leaf. When you say a leaf on a tree, you just pluck it out. But it has no children. If there was a leaf on top of that leaf, then it's no longer a leaf. We call it something else. So that is exactly what's going on here. You take it out. You take out the leaf. And so you have to insert in the leaf. To insert something, you have to insert at the bottom. But you have to start looking for where to insert it from the root. So it goes in here, 284 is greater than 72. So which way does it go, left or right? Since 284 is greater than 72, it goes to the right, kind of like a BST tree, basically a BST tree. It goes to the right, it checks the node. Okay, this node is a leaf, so it checks where it's going to place 284 in it. 284 is bigger than 177, it's bigger than 228, so it's going to place it here. So watch this. Boom, 284 is over here. We still have our 9 on its own. We still have 2 children. We still have one root. So we can do this all day. Let's insert 1. It's gonna insert 1. You see, 1 is smaller than 72, so it goes to the leaf of where it's smaller than. It goes to the left. So it goes forward. You see, it's going down, and now it looks for where it's going to place 1 in this node. And since the node is, is a big node and we only have 9 in it, it's going to put it right in front of 9. Boom. Look what happened. In this child, we have 3 keys, meaning this is the maximum amount of keys we can have. So let's say we want to place a value greater than 72, like 169. We want to put 169 inside. Okay, let's see. Look at this. 72. It goes to the right because it's greater than 72. Guess what? 169 is inside. But now we have 4 keys. We're violating the rule. What are we going to do? We have to split it. So we're going to split this, and the median goes up, and this splits into 2. So watch this. The median was what? 177. Let me show you again. 177 is the median. If you do the median, so we have 4 keys. So the median will be t minus 1 over 2. So it's going to be 4 minus 1, which is 3 over 2. And 3 over 2 is 1. Is 1 basically, in coding. So we're going to have to take the 1. So this starts on 0, 1, 2, 3, right? So we're going to have to put this 1 up. So, step forward. 177 goes in. Well, whatever was before 177 goes to the left. Whatever was after 177 goes to the right. That is basically what governs it. So, we have that. Let's insert more. Let's insert 263. Inserting 263 in it. Watch this. We're going to insert this. So it goes here. It says, where can we put 263? 263 is greater than 72. It's greater than 177. So we go to the right, which is this child. So it goes forward. It goes to that child. Ooh. We check. Where can we place this in the child? It's right. 263 is bigger than 228, smaller than 284. So it goes in the middle. 263 is right in the middle of this. Beautiful. Keep pushing, keep pushing. Yo, this is my first YouTube video, so it's gonna sound grandiose, but I'm just gonna explain this. There will be more. It's gonna be better, better audio. If I make money from this, I'll probably get better guys to show you guys. But this is basically what's going on right now. So I'm putting 237 in. I'm inserting this. Inserting step forward. Ooh, you see, we have a 237 is greater than 177. It goes to the right child. It puts that in there. Well, guess what? It puts it in. We have 4. It's greater than 3 keys because we had a max degree of 4 and we can only have t minus 1 keys in it. So we have to split that and we got to put that up. So step forward. We put in the median. Whatever was before the median. So let's go back. See, we had 237. 228 is before it. 263, 284 is after it. So 228 goes to the left. 263, 284 goes to the right. Step forward. 237 goes up. 263, 284 to the right. 228 goes there. Beautiful. Guess what? We've got that. Let's add more. Let's see what happens. Let's see if we have what did I just add last? I think I added 237 last. Let's add 63 in there. Step forward. So 63 comes in here. 63 is less than 72, so it goes to the left. Step forward. We have the leftmost child. Step forward. We put in 63 in there. It's full. We have the right amount of keys right now, so nothing, no splitting, nothing is going on. Now let's put in 22. So we insert, step forward, 22 goes to the left because it's smaller than 72. It goes down. Step forward. Guess what? What do we have to do? We have to split this fucking node. Because why? Oh, no. We have to split this node because, it's full. So we have to split it. We got to put it down. So 9 goes up, the median. Whatever was before 9 goes to the left. Whatever was after 9 goes to the right. Guess what? This is full now because we have 4 keys. So what do we have to do? We need to split this node too. So same thing, the median will be 72. 72 will go up. Whatever is to the left goes to the left. Whatever is to the right goes to the right. So we step forward. Now guess what happened? This had children. So we have to split the children too. Right? So meaning we have to split the children by the median too. So we have 5 nodes. So 2 of the children will go here and the remaining 3 will go to the right. So we split the children. 72 goes up. This goes down. 9 has this children. And this node has this children. And that's basically the basis of BTree. We can do this all day. We can keep adding more stuff in it. So, 148. So you can see 148, it has to always add at the leaf. 148 comes in here, it's bigger than 72, but it's less than 177, so it goes this way. And 148 can sit in there, and we can keep adding all day. That is basically the basis of BTree. So I've explained to you that this is how a BTree works. We have to always add in at the leaf. So let's write it down here. Rules of a BTree. We have to always add at the leaf. What else do we have to do? We have to always the nodes always have to have the degree, max degree, minus 1 keys. That's the maximum. Max nodes. Max keys in node. Oh, I have to buy handwriting, so forgive me about that. But yeah, max keys in node always has to be max degree minus 1 keys. What else do we have to know? If it's full, we have to split the child. If the node is full, we have to split it. When splitting it, what do we have to do? We have to always push the median up. So push the median up. What else do we have to do? We have to push the median up. Things after the median goes to the right. Anything before the median goes to the left. And what else do we have to do? Then we have to what else we have to do? We push that to the left. If it has children, then we give the children half of it, or like the median of it, and we give the left the median of it, and we give the right. We split the children into two and divide it by. So the left has, so if you have a children and we have 5 children, 5 divided by 2 is 2. So 2 of it goes to the right and the rest goes to the left. So half of it to the right, the rest to the left. And that's basically it. The rest is history. I'm going to write the source code for this, and I'm going to show you how I'm going to write the code and how a BTree works. So BTrees are useful, when we in like external disks. So we have our trees could be used in our normal, RAM, our normal main memory. But like a BTree is used to like, you can see how much space this saves. This tree is much smaller. The tree that we built here is much smaller than oh, I cleared it. But the tree that we built here is much smaller than a normal tree would have been with all these keys. And that's what a BTree does. It saves space and it gets things faster. So, it may be a lot to like, look at, but it is what it is. I'll see you guys in my next video. Have a nice day.